Hi, welcome to another 4AC video. This time we shall look at quiz, one of the quiz that we've just done, quiz 4. There are two sets. In this video we look at set A. Now set A reads that a 230 volt 50 Hz AC supply is connected to three loads as shown, and we are asked to calculate the branch current flowing through I1, I2 and I3, and to calculate the real power, reactive power for load 1, load 2, load 3. And part 3 wants us to calculate the overall apparent power, and finally determine the overall power factor. And finally, part 4 wants us to calculate the capacitor required that we need to add here in parallel with the rest of the load to raise the power factor to unity. Well, let's see how we can answer this question. Well, to answer this question, what I've done is to quickly sketch out the circuit and to identify that this circuit is a circuit whereby there are three loads in parallel with the supply. Now, when we have parallel load, we must recognize that the voltage across each of these loads are the same. Okay, so that we can apply the necessary formulas to calculate what we want. So the first thing we want to do is to calculate the three branch currents. So if we look at load 1 has only a resistor, so that's quite straightforward. We use the polar form to answer this question. Using Ohm's law, E divided by the impedance of Z1. So that gives me 230 volt divided by 150 angle 0 ohm. So that will give me 1.53 at the angle of 0 degree ampere. Okay, that's the branch current for 1. Next, we look at load 2. Now, the information provided is a little bit different. I know the apparent power for this particular load, which is 1500 VA. Now, this time there is a power factor given. So I need to find the angle that is for this particular load only. So FP is cosine theta 2 is equal to 0.75, which I can translate the angle to be 41.41 degree VA. Right, so to calculate current, I use the formula S2 divided by E2, or rather E, right? So that will be 1500 angle 41.41 degrees divided by 230 volt angle 0. That will give me a current of I'm sorry, this should be conjugate. So the current I get from here will be 6.52 angle 41.41 degrees amps. But I2 will be the inverse conjugate, or rather conjugate, so that will be just the same value but with a mirror image angle. So that is I2. And finally I3. Now I3, I need, since the information provided is regarding the impedance, I can convert this impedance into its polar form. So Z3 is equals to, using my calculator to convert, I get 82 angle minus 37.57 degrees ohms. So I substitute that inside here. So what I get is E divided by Z3. Right? that is 230 angle 0 volt, divide by 82 angle minus 37.57 degrees. That gives me a current of 2.805 at an angle of 37.57 degrees ampere. Right, so I will have this is my answer. Okay, I want to highlight this so that I can see clearly. Okay, this is the first current branch 1, current branch 2, and finally current branch 3. Alright, so that is the 3 branch currents. Now I want to focus on calculating the true power and the reactive power. Now for load 1, is, since it's only resistive, I can use the formula I square times R. That means 1.53 square times 150 ohms. That gives me 351.14 watts. The true power for load 1. Q1 is equals to I1 square times 0 because there is no so-called reactance. So I will have 0 VAR. For P2, now P2, I make use of S and the angle that I've calculated earlier. So I can have S cosine theta. So it equals to 1500 times 0.75. That gives me 1125 watts. Then for the reactive power is S sine theta, the 2. So that's 1500 times the sine of this angle. The sine of this angle is just, okay, let me just write there. Sine 41.41 degrees. That gives me a value of 992.16 VAR. This is not the units. This is watts, this VAR. And finally, we come to the last part. Now, last part, we can make use of the original impedance version. In this example, it means that there is a 65 ohm and there is a reactance of negative J. Negative J means there is a capacitor inside there. So this time, I can make use of the same formula that I use in load 1, I3 square R3. That's equals to 2.805 square multiplied by 65. That will give me 511.42 watts. Similarly for Q, I can use I3 square. This time Q is 50. Right, Q3, yeah. Not Q3, sorry, X3. So that's equals to 2.805 square multiplied by 50. Notice the negative there. Negative means capacitive. So I have 393.4 VAR but negative. Alright, so that's my real power for load 1, reactive power for load 1, real power for load 2, reactive power for load 2, and real power for load 3, and the reactive power for load 3. Now to calculate the total impedance, total apparent power, all I need to do is add up all the P's, P1 plus P2 plus P3 plus J of Q1 plus Q2 plus Q2. So all these numbers add up to 351.14, 1125, and so on. I add them up, I would get the number 1987.56 plus J. Now J this time there's 0 here. There is 992.16. But notice this is negative. So 992.16 minus 393.4. That gives me 598.76 VA. Or in the polar form, I have 2 zeros, 75.79 at an angle of 16.77 degree VA. Okay, so that is the apparent power. Now, which means that the new power, or rather the overall power factor of the total, is the cosine of 16.77 degree. So that's that will give me cosine of 16.77. Check again. Cos 16.77, 0.957, 0.957 lagging because it's positive J, lagging. Alright, so these are my answer for part 2 here. Part 2 is this, and this. Whereas part 3, the total apparent power is this, and the power factor is this. Alright, we have done part 1, 2, and 3. Now part 4 wants us to look at the overall power factor, which was 0.9. So if I 0.95. So if I were to draw the power triangle, I would have P 1987.56 watt and a reactive power Q equals to 598.76 VAR, and which gives us an apparent power of 2075.5679, sorry, VA at the angle of 16.77 degree. Now, if you want to improve the overall power factor to 1 or unity, it means I want to do it in such a way that this angle becomes 0. Now, in order for this angle to become 0, I need to introduce a capacitor in parallel with the overall circuit. Now, imagine this is the overall circuit. I want to introduce a capacitor here into this circuit, right, to the AC supply, such that the power factor becomes 1. So to do that, I must introduce the reactive power by this capacitor, such that it cancels out the total Q here. Right? That means I need to introduce something that has a value of 598.76 VAR, but it's in the opposite direction. Opposite direction means in this direction. So if I could cancel it out, then my S becomes the same as P, and my angle becomes 0. Okay. Now we know that QC, if you introduce here, is just E squared over XC. the reactance of this capacitor. Rearranging this formula, I can then get Xc is equals to E square, which is E square over Qc, which is 230 volt square divided by 598.76. That gives me a value of 88.35 ohm. However, we also know that Xc is equals to 1 over 2 pi Fc, where F is the frequency, which we are given as 50 Hz, and C is the value of the capacitor we want to put here. So rearranging this formula, C is just 1 over 2 pi F Xc, which is 1 over 2 pi, put in the 50 Hz, and put in the value of 88.35 ohm. So use your calculator and it will give me an approximate about 36 microfarad. In other words, I need to put in a capacitor here of this value in order to improve this circuit in such a way that the power factor becomes 1. Well, that's all for this quiz. I hope you learned something today. Bye.